In box, an equivalent version of theorem 1.2 was probably first recorded as proposition 14 of book 9 in Euclid's Elements. Before it came to be known as the fundamental theorem of arithmetic. However, the first correct proof was given by Carl Friedrich Gauss in his Disquisitions Arithmeticae. Carl Friedrich Gauss is often referred to as the Prince of Mathematicians and is considered one of the three greatest mathematicians of all time, along with Archimedes and Newton. He has made fundamental contribution to both mathematics and science. His time was 1772-1855. Now, the fundamental theorem of arithmetic says that every composite number can be factorized as a product of primes. Actually, it says more. It says that given any composite number, it can be factorized as a product of prime numbers in a unique way, except for the order in which the prime occur. That is, given any composite number, there is one and only one way to write it as a product of primes, as long as we are not particular about the order in which the primes occur. So, for example, we regard 2 into 3 into 5 into 7 as the same as the 3 into 5 into 7 into 2, or any other possible order in which these primes are written. This fact is also stated in the following form. The prime factorization of a natural number is unique except for the order of its factors. In general, given a composite number x, we factorize it as x is equal to p1 into p2 into dot 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 pn, where p1, p2 and pn are primes and written in ascending order, that is the p1 is lesser than the p2 is lesser than the p3, likewise pn is greater than pn minus 1. If we combine the same primes, we will get powers of primes. For example, 32760 is equal to 2 into 2 into 2 into 3 into 3 into 5 into 7 into 13 is equal to 2 to the power 3 into 3 to the power 2 into 5 into 7 into 13. Once we have decided that the order will be ascending, then the way the number is factorized is unique. The fundamental theorem of arithmetic has many applications both within mathematics and in other fields. Let us look at some examples. Example number 5. Consider the numbers 4 to the power n, where n is a natural number. Check whether there is any value of n for which 4 to the power n ends with the digit 0. Solution. If the number 4 to the power n for any n were to end with the digit 0, then it would be divisible by 5. That is, the prime factorization of 4 to the power n would contain the prime 5. This is not possible because 4 to the power n is equal to 2 to the power 2n. So the only prime in the factorization of 4 to the power n is 2. So the uniqueness of the fundamental theorem of arithmetic, that there are no other primes in the factorization of 4 to the power n, so there is no natural number n or which 4 to the power ends with the digit 0. You have already learned how to find the HCF and LCM of two positive integers using the fundamental theorem of arithmetic in earlier classes without realizing it. This method is also called the prime factorization method. Let us recall this method through an example.